Hi guys, welcome again to our class. In our today's class, we are going to talk about electrochemical cell. Now, we will start with types of electrochemical cell. Now we have primary cell, we have secondary cell. Now let's start with primary cell. This is a cell used to generate small current of electricity and which is replaced once the chemicals in it are depleted, e.g. Daniel cell, cadmium Weston mercury cell, and Leclanche cell. They are used in torchlights, radios, and bicycle lamps and are non-rechargeable. Like those finger batteries that you know, finger battery, they are the type we are talking about in this case. Once they are dead, you throw them away, replace them with new ones. So those are primary cell. So this is the lead accumulator. In the car battery, you have the casing, you have two poles, positive and negative. One positive is cathode, negative is anode. And then you have electrolyte. Inside the electrolyte, you have this. This is the electrolyte. This is the anode, lead. Metallic lead is anode. Lead 4 oxide is the cathode. Now, at the anode, what happens at the anode is that lead Pb will, which is solid, will ionize to form Pb2 plus. The two electrons are moving. This is electron, this is electron, this is electron. So atoms on the surface here will donate 2 electrons. Each atom of lead will give out 2 electrons, and then those electrons will flow down. And the remaining ion, lead ion, Pb2 plus, that donated the 2 electrons will go down to the electrolyte and take SO4, 2 minus. SO4, 2 minus, to become what? PbSO4. And then it will stick on the surface here and cover the surface of the real lead. And at some point, the surface will not be allowed to get in contact with the acid for the reaction to continue. Now, those electrons are flowing down. Let's see what happens at the cathode. Remember, we are still talking about discharging process. When we say discharging, we are talking about the battery giving out current. So now at the cathode, you now see that what will happen at the cathode is that the electrons that are running from the anode are coming to meet PbO2. Remember, those electrons are there. The electrons are there. They are coming there. And then hydrogen from here, hydrogen ions in this electrolyte will also come up. They will come up and then react with this oxygen here, with that electrons, 2 electrons, with that electrons, hydrogen ion will come up and then react, 4 of them will come up and then collect the 2 oxygen from here and then react with these 2 electrons that are flowing down and then form Pb 2 plus and 2 molecules of water. 2 molecules of water is formed also. Now, in that process, you can see that this PbO2 have separated. Now you have Pb left. Now, this Pb will not remain here on the surface alone. It will now do what the Pb of this one. Remember what happened when this Pb was formed on the surface? It looked down to the solution and collect SO4 and react. So that is the same thing that will happen here. This on the surface here, it has changed from PbO2 to Pb2 plus, and SO4 2 minus are still here. So this Pb2 plus will look into the solution and collect SO4 2 minus to react and become PbSO4. Now you can see that both here and here you have PbSO4 covering the surface of the 2 electrodes, and that's the time your battery will become low. Your battery will not have current again. It will not be able to start your car until you remove it to the roadside electrician to connect it into the direct current from the electricity, and then to reverse that recharging process, the power is no longer coming out from the battery. You go to recharge the battery. In recharging process, that's different from discharging. Discharging means giving out current. Recharging, collecting back power. So now, taking the battery to the electrician, you want them to reverse the process and then remove the PbSO4 from this surface, and also remove PbSO4 from this surface and return it back to the previous state when the battery was powerful, so that you can make good use of it. Now we are going to move to recharging process. Now we are done with discharging. Now let's see, during recharging process, when you are recharging your car battery, what happens? Now we are recharging. Now the car battery is connected into the external electrical supply. This is electrical supply. Now anode, the current is flowing from the anode into the cathode of the battery and moves in and get out from the anode of the battery back to the external source of electricity through cathode. Now let's go again. Current is flowing from anode into the battery through cathode. Now what happens to the cathode? Remember that the surface of this was covered with PbSO4. Both of them were covered. Now, and the battery did not get power. You are connecting it now. So when the electric current, the electrons are coming into the battery through the external source from the electricity, what happens to the cathode? Now let's see at the cathode. What happens here is what I've written in this place. Now at the cathode, the PbSO4 that covered the electrode, remember this is supposed to be Pb electrode, not PbSO4 as we saw. So the PbSO4 that covered the surface, because electrons are coming in, the Pb will let go SO4 into the solution. You can see SO4 going back to solution from here. It goes back to solution, leaving you with what? Pb. Then the Pb will collect the electrons that are flowing in, just 2 electrons each. One of these will collect 2 electrons to form this. Another one will collect 2 electrons to form this. Remember, as it is allowing SO4 to go back to solution, so this is removed. The PbSO4 is going off the surface of the Pb. Now you have back your Pb. Now what happens there is that the Pb is restored. Now let's see at the anode, which is this place, what happens there. Now remember also that PbSO4 covered the surface of PbO2. Now when the electric current keeps flowing, the PbSO4 will release SO4 back to solution that it came from. The SO4 from here will fall to the solution here, leaving you with Pb2 plus. And that Pb2 plus, remember, hydrogen, 4 of them came from the solution to react with it. They will return back to, they react with it to form water molecule. So the 4 hydrogen here will go back to the electrolyte, leaving the oxygen to this Pb. Remember, electrons came also from this other side to that, and those electrons are removed again. They are joining in moving upward to this other side. So the electrons will be delivered again back, and then the Pb will now collect back the oxygen and then let go SO4 into the solution. So that's what gives you this. You have restored back your PbO2. This goes back to solution. So now you have your Pb formed. The surface will be cleared from PbSO4. Now it is back to what? It is back to PbO2. So you have restored your system. So the battery is fully charged, ready to be used. By the time you get back from, collect it back from your electrician, fix it in your car, put key, it starts. Notes: after recharging your car battery, the density of the acid in the cell returns to the initial value due to the release of the same amount of ions into the solution. 2. The EMF, electromotive force of the cell, returns. Now let's see the differences between primary cell and secondary cell. Primary cell this side, secondary cell the other side. Number 1, under primary cell cannot be recharged. Remember, finger battery cannot be recharged. Secondary cell can be recharged. Car battery can be recharged. Number 2, chemical reaction is irreversible. Chemical reaction is reversible. Number 3, the internal resistance is high. Here, the internal resistance is low. Number 4, chemical energy is converted to electrical energy when current is drawn from it. Here, electrical energy is converted to chemical energy when current is passed through it. Number 5, it is light. Number 5 here says that it is heavy. Here, it is less expensive. Here, it is expensive. I believe you enjoyed the lesson. I would ask you to keep sharing and keep following this channel. Like the channel, subscribe to it, and then keep on following the channel for more teaching. Thank you.